anything if you don't want it recorded. Okay, that's the recording and the transcription started. And as I said, you won't be surprised to know we're moving on to the chapters. And today we are getting to file systems. Hopefully you've read ahead and you know that. And none of the stuff that I'm saying today will be a surprise to you. Sorry, my system's just slowed down completely. Oh. So we'll be covering all aspects of file systems and trying to understand how they get together. And as part of that, of course, we'll be looking back at ways that we can go about setting up file systems, some of which, of course, were used in early operating systems. But it's always worth remembering how we got to where we are. And the other thing that's worth remembering is when we talk about file systems, same caveat as usual, don't just think about your system, don't just think about what happens on a Windows box or a Mac box, whatever you're using. Think of them more widely, because we've talked about it before, operating systems cover a lot of range and a lot of different types of computer. So it's not just the machine on your desk. If we're going to talk about file systems, we should probably say what a file is in the first place. And as far as we're concerned, a file is just a contiguous logical address space. And the logical part's important because where we store the file, it may not all be in one chunk. It might be split up. We've got all sorts of different types of file, and they might have different attributes attached to them. And again, don't get too hung up on what they are. The ones that are on the slide there are common ones. You know, a file name, the file type, what's the file going to be used for? Is it a document? Is it a text file? Is it an image? Is it an executable? So all the things on the screen just now are fairly reasonable, and most operating systems have those. And sometimes an awful lot more besides. So, for example, here is what you get if you look at file information on a Mac. Now remember that a Mac, underneath its fancy shell, is actually Unix. So you'll see a lot of crossover with what Unix does. So here's a file system for Mac file, and it's got a name, it's got an extension, it's got a file size. Excuse me, it's got a file size, it's got when it was last changed, but a whole bunch of other stuff as well, including where it lives, when it was created, who modified it, some stuff that wasn't on the previous slide, like a label. So in the Mac operating system, you can give them a label and give that colors. You can decide what application you want to open files that have a .tex extension with, and you can say who you're going to share it with and what kind of access you give other people. And that's important for systems that are shared with other people, which for us quite often is a lot. You guys are working in a group. I'm kind of hoping that at some point you have set up a shared area on one of your OneDrives or on Teams where you can share files and you can all edit and all do that kind of stuff. And if you haven't, why not? Wouldn't it be easier to work together like that? So if we've got these files, we're going to have to do stuff with these files, like create them and read them and write them. And again, as we saw in previous lectures when we were talking about other things, there will be built into the operating system an API, an application program interface, that allows anybody who's writing a program not to have to worry about um, the detail of how the file's saved, where it's going to go, how that's going to be set up. You just say, save a file at a particular location with a particular name, and don't bother me with anything else. Similarly, you can open it up again. When you do open it up, you can look for particular things in it. So I am going through this PowerPoint file. I could quite easily say, please go to slide 30. And it would jump through the file to get to slide 30. So again, there will be different things that you can do. These are kind of fairly basic set. And other operating systems might have more or fewer functions. Sorry, what's the same with Chromebooks? I just noticed that there, and I don't know if it's something I said before. I'll move on. You can add some extra. Bless your heart. Linux, yeah. So Chrome is based on Android, which is based on a Unix shell. Yeah, a Unix kernel. Right. So, at its most basic, if we have a file, we probably want to open it. Now, it's important we keep track of open files because it's important we close files afterwards. If you're on a single user, single tasking system, that's not so much of a problem because when you close down your computer, everything closes. But remember that as with other things in the operating system, we have to keep track of things. And if you continually open files and don't close them again, sorry, Connor, I just noticed your face when you ate that. I was actually thinking that tangerine looks really nice, but I'm guessing it isn't.
Yeah, I thought the same until I ate it. Thanks.
So we're continually opening files. We need to keep track of the files that we have open, where they are, and what they are. If we keep doing that and don't close them, that bit where we're keeping track gets bigger and bigger and bigger and bigger until eventually it falls over itself. So it's important that we not just open the files, but we close them down again afterwards. We'll also need to know where we were. If we're working our way through a file, if you've opened a Word document and you're working your way through, looking at each page, you have to know where you are as you're reading through that file. So you need to know where you are. You might be sharing a file. So it's important to know how many people have it open. And you can do that. So if you set up a group report in your OneDrive, for example, did you know you can all edit it at once? And you can see multiple cursors with initials against them to show where people are and what they're doing. You can do the same sort of thing with Excel and that kind of stuff. But of course, it's important to know how many people have that open. And that becomes even more important where you don't realize that you're working together. So say you're in a big call center and somebody opens up Alan's record to phone him up to sell him a subscription to Bunty magazine monthly. Of course, he's going to accept and he's going to update that. But in the meantime, somebody else might have Alan's record opened up. So they sell Alan his copy of Bunty magazine. They put that into the database. That gets saved back, but someone else has opened up Alan's record in the meantime because they're going to phone him because he's just next on the list. They realise someone's already taken the call, so they close it, and that then overwrites Alan's subscription. So you need to be careful about who has a file access and who has the rights to save to. And again, you can sometimes see that if you work together. You'll see things like, this file has changed since you started working on it. Would you like to save a copy instead? So the operating system has to take care of all that kind of stuff. It also has to take care of whether you're allowed to access it at all. And we saw that with the rights. We saw that with the rights that we had here. Who gets to read it and write it? Who just gets to look at it? And who's given no access at all? That fancy name for that, where you stop people editing because you're editing, or stop people changing, is called file locking. So it basically says, this file is open, someone else has got it open, they're doing something with it. I'm not going to stop you accessing it, but you'll have to access it in read-only mode. So you can look at it, but you can't change it because someone else has it. That's an exclusive lock. Although sometimes you can have something called a shared lock. The idea being that you can share a file. So if you have that sort of thing where you have a huge database file and more than one person wants to access it, you can, often the operating system will give you record label locking. So the file isn't locked, but the record that you're looking at is locked, so only one person can update it. In fact, companies like Oracle made billions of dollars setting up that kind of thing. Because we think of Oracle as a database, Oracle is really more of an operating system, because it's all built into the operating system. And you install it to make sure that the database can work properly. And then the operating system can allow you to decide what kind of locks that you have, whether they're mandatory or whether they're only advisory. And again, that'll depend on the kind of work that you're trying to do and how it thinks you should progress. We also have lots of different file types. Operating systems will quite often use a visible file type. So you're all familiar with files that end .exe, so they'll have an extension. So you can look at it and go, oh, executable, oh, text file. There's nothing says that it has to be visual. So if you go into Unix, you might have a file called thread. Now there's nothing in that file name that says what it is. That doesn't mean it's not stored somewhere. It just means that it's not required. And the reason we get so used to it is DOS and its successor Windows required an extension to show the type of file as it was. But that's not required. It's just a choice that they made. And there's nothing to stop you even in a Windows system. If you see a .txt file, you might think, yeah, text file, open it with Notepad. Some of you might even have gone on to open it with Notepad++ or WordPad. But there's actually nothing in the rules that says, well, if I see a text file, open it with Chrome. Or actually, if I see a file with .txt, I'm going to set that up as all my executable files are going to end .txt. It's not a rule, it just is a link. So same as it is here. It's just a link and it says, well, if that's kind of file, here's what I'm going to use to open it. We also have different types of file. Now, again, this is one of the ones where I want you to remember that we're not just talking about your Windows desktop. You get different types of files for different types of job. So you could have a simple file, so a text file, just lines of text. But there's nothing to say that that text can't have meaning. After all, an HTML file is just a text file that when you put it into a browser, gets parsed in a particular way to show fancy stuff on a screen. So we can have simple files. We can have ones where they are fixed length. So we might have something like a transaction in a shop that says it's a fixed length, and the first 6 digits are the date, and the next 4 characters are the time, and the next 16 characters are the credit card number, and so on and so on and so on. And we can set up a fixed length file where we know what each part of the record is showing. And for record, you can read line in this case. Or you could decide, no, actually, just have them variable. In a text files like that, you can have different lengths of line on each of them. And that's why you've got a simple record structure. So you can, in essence, open it up, look at it, and get an idea of what it does. That's if you don't move on to a binary style file, where you have a complex structure and you can have all sorts of information in there. And it's up to the application program to sort that out. And we do that by not restricting ourselves to basic characters. We can use any binary value. And the program or the operating system can then use that to decide what we're going to do with the file. As ever, if you have questions, stick them in the chat. It's nice to see the chat going, even if it is David just moaning about people not letting him change the line he's doing. It can be a pain. So we've got different access methods as well. And this is one we don't often think about. This is sequential access. And it used to be that I would explain that to people with a cassette tape. And of course, people don't use cassettes anymore, so you don't know what I'm talking about. But on your screen just now, you're seeing a vintage tape drive, an IBM tape drive, actually. And you can imagine the data being stored in that. So say you're a bank and you have a transaction, you don't really need to store those in any particular order. You just have a transaction, store it, have a transaction, store it, have a transaction, store it. And something like a simple tape drive does that really well. So you have each bank location has its own computer, and you store all the transactions on a tape. And then later on, you take those tapes and you go through them and you reconcile the transactions that have happened during the day with your account. And you've probably kind of come across that, where you've spent something but it hasn't quickly come off your account and it only happens overnight. Or if you've got a paycheck, it's happened overnight because there's a list of people that are going to pay and it gets run overnight. And even though I'm showing you a 1959 IBM tape drive, that's misleading. Tape drives are still integral to large computer systems. Don't know what's up with my IT today. My daughter must be downstairs watching Netflix or something. They're integral to a lot of systems because, well, does anybody want to guess why they're still well used?
Because they're cheap and they offer cheap large storage.
That's the only reasons I can think of.
And they are the reasons. It's cheap and you can get a lot of data in there. So people will still install tape libraries, massive big cabinets full of tapes, so that you can do archives or so that you can save a lot of data. If you're saving stuff onto one of these cloud systems like AWS or Azure, do you really think they've got a whole bunch of hard disks? And I mean, they do, but a lot of the stuff that's stored onto these things is rarely accessed. So what do? You put it onto something that's really cheap and can store terabytes of data. That's what they're doing here. They're setting up all these cabinets. Each one of those wee red boxes is going to store 8 terabytes of data in one wee box. Look at how many cabinets and how many of those fit into each of those cabinets, and think about how much data you're storing with that. And I really want to get this one going because, of course, if you've got that many tapes, you probably don't want to access them manually. Instead, you want to set up a wee robot that will go grab your tape, put it in the tape drive, and read the data that you want. And these are still used in massive systems because they're not storing a bunch of Word documents and some videos. They're storing terabyte upon terabyte upon terabyte of data that can't be lost. And so these are cheap, they're big, and it's easy to keep a copy or multiple copies, and it doesn't cost a fortune. And all of those tape drives use sequential access. You read a bit, then you read the next bit, and then you read the next bit. And if you want to jump over 100 records, you have to physically zip through the file in exactly the same way. You have to physically zip through the tape in exactly the same way as you did in 1959 with this kind of tape drive. The same sort of thing that you see on a vintage sci-fi film. So we'll have sequential access. And it is slow, yeah. It is slow, Connor, because you don't have random access. You only have sequential access and you have to zoom through them to get to where you want, which is why it's better for particular types of storage. So as I say, if you're storing a whole bunch of transactions, you don't really care what order you're doing them. You're storing them and then you're going through them to process them. You're not sort of zooming back and forth to try and get a different bit. And that's what I'm saying, Kelly, it's not vintage. It's absolutely up to date, even though we don't think it is. If you're doing a backup, if you're backing up your hard disk, you don't mind that it's slow to get to a particular part of the disk. Because if something happens and you lose your hard disk and you want to restore it, do you know you'll wait that extra 30 seconds till the tape spools through to get to the bit that you want? Because if nothing else, it means that you can buy a new tape for a £5 every day and back up every single day, and it's not going to break the bank, particularly if that data requires to be stored. If we don't have sequential access, then we've got direct access, and that's the one that you're more familiar with. You can just have a type of storage system that can go immediately to a record. And that's just pointing out that when you have these types of file structures, keep doing that, keep pointing to my screen instead of yours. When you have a file structure with a simple record structure, then you simply go through it by saying, okay, you start at the beginning, add on whatever you need to the pointer to get to the next record, and then keep going. You can start to expand that out. So say you do have a 4 terabyte tape drive and you've got a 1 terabyte desktop system and you want to connect up your backup tape drive to your desktop. Well, the first time you back up, you've maybe got 0.5 terabyte and that goes onto the tape. And then the next time you back up, well, you're not backing up everything, you're just changing you're just backing up what's changed. So you might have a couple of gigabytes and then another couple of gigabytes. So you end up with a whole set of backups all in that one tape. So you might want to add on to your storage method by saying, okay, well, rather than just putting them one after the other, let's have a wee index so that we know how far to spool through that tape. So we can start to create an index saying, okay, well, at position 10, we've got this back up here. And at position 120, we'll get that back up here. And even within that, you can say, okay, well, within this backup, we have file 1, file 2, file 3. In other words, we have an index that says where things are. And I'm talking about that for a tape, but of course we have indexes for everything. If you're doing it off a tape, then you go, you read the index, you read where the file's going to be, and then you go to it, and that is slow. But actually the same thing happens with a disk. You go to the disk, you read the index for the disk, and then you go to the place on the disk. So you tend not to read the index every time. Instead, you keep the index in memory. So when you start up with your disk, you bring in the index, and if it helps, whenever I say index, think of list of files or directory structure or however it helps you to visualize that. When you start up, you read the index and you bring it in so that when you need that, you can go directly to the file on disk. Anybody see any flaw in that plan with your 1 terabyte disk?
Just to do with the size, it'll fill up so quickly.
Yeah, your 1 terabyte disk could have hundreds of thousands of files on it. And if you have to have an index for each one of those files, well, you do have to have it because you need to know where they are. But if you're going to bring that whole index into memory, you're going to have a problem. And you won't have room for anything else with those hundreds of thousands of files all being indexed in memory. So you can have dual layer indices. So you can have an index of the index. So you can balance it so that you can say, okay, let's bring in the index of just the directories. And then when we need something in the directory, we'll go to the disk and we'll read the index of that directory. Other operating systems could do it in other ways. They could look at, and we've looked at these before for other reasons, most recently accessed, least recently accessed, all that kind of algorithm that we can use to decide, oh, which ones do we actually need? And different operating systems will implement different versions of that. And you see the one there called indexed sequential access. And that's what I'm talking about for the tape. So you keep an index, but you still have to sequentially go through the tape to get it. But the key point to all of this is the user doesn't know about it. The user doesn't care, the operating system takes care of that for them. And ISAM is used daily. It's still a big thing in commercial systems. VMS, not so much. There's still some about there, but mostly virtualized now. But it's not the point because we use these same sort of structures now. So we can have an index that says, okay, we want to look up the record for John Smith, and that then tells us where it is in the file. So the file itself can have an index. And again, think database. It doesn't take long to get to a file in a database, and you do that by looking up the index. And databases can have multiple indices. Look it up on surname, date of birth, car registration number. It's entirely up to you, and it depends on the application that you're running. Everyone happy with that before we move on? Okay. So quite often what you'll want to do is not just have a whole pile of files. Instead, you'll want to organize them somehow. So we might want to set up directories. Windows calls them folders. It just says, okay, well, all the files in here pertain to something. All the files for a particular application, all the files for a particular user, all the files for a particular project, whatever it happens to be. So we're going to have to think about how we set that up as well. So before we do that, let's pause to think of what we actually have as a storage medium. So we've talked about tapes, where it's just a whole series of data, one after the other, for serial access. And we mentioned that we had direct access for newer devices like disks. But it doesn't just happen by accident. We need to set up that disk. So the first thing we can do is give the disk a partition. Now, often disks only have one, and the disk and the partition are the same thing. But sometimes you can have multiple partitions, and you can divide them up in different ways. So we were talking about backing up your machine. The first thing I do when I get a new machine is I split the disk into two partitions. One is for operating system and executables, and one is for data. And what I do when I'm setting up my backup is I say, back up my data partition, ignore the operating system and executables partition. Why? Because I can reinstall those. I was going to say I have the disks, but it's not a disk anymore, most of the downloads these days. But you get the point. I don't need to keep a copy because someone else has kept it for me. The data, on the other hand, is mine, and I want to back that up. So that means that my backup is much faster. I'm only storing the stuff that I need to. So you can do that in different ways. It can be for that. It can be for different users. Each user can have a partition on the disk. You can have it for different reasons. So it might be that you have a media machine, and you decide that one partition is going to be for general computing, and one partition is going to be for video rendering. And that's important because the other thing that you have to do to a partition is format it. And again, we tend not to think about it. Occasionally we'll stick in a new USB drive and it'll ask us whether we want FAT32 or FAT64 or FAT16 or something. But actually there's a whole queen. Queen's a technical term, by the way. And if you're not from Scotland, it means lots. There's a pile of different file systems that you can use. And you can format them based on what you're going to use that partition for. So if you've got huge video files where you know that each video file is going to be 4, 5, 6, 10 gigabytes, you might want to choose a different file system than if you've got a general purpose system where rather than having a few large files, you've got lots of small files. So when you set up that file system, that's then called a volume. And again, sometimes you'll have seen that if you stick in a USB drive, it will say installing volume Fred's USB. And one of the things that the file system will have is some sort of organization to it, a way to subdivide it into directories and to know where things are. So you can end up with quite complicated file systems. You can have multiple disks. So here's a single machine with 3 different disks. Disk 1 is partitioned twice, one for executables and operating system, one for general purpose files. And the third one here is set up with a different type of file system. And it's for the example, this could be for the example I was giving you for video rendering, where we have 2 disks, where the one partition covers 2 disks, because we know that we're going to be using huge files. So rather than saying, oh, well, is it on drive D or is it in drive E? You just say, no, it's on my videos partition. And let the operating system sort out whether it's on disk 2 or disk 3. You just treat it as one huge partition. So we've got all of these kinds of options. And if you think about it, of course you do. Do you really think that when you go into your OneDrive and we all go onto our OneDrive. Do you really think that's one disk somewhere sitting in a machine? Of course not. It's a whole pile of different devices that are logically treated as one drive. So as I said, we can have we do have lots of different file system types. They are for different reasons, for different applications, for different purposes. And you would choose those. Now, hopefully, many of you, given that the assessment is to talk about Linux, hopefully you have by now installed Linux in at least in a virtual machine. And one of the things that Linux asks you when you install it is, what type of file system do you want? So it's more, you can tune it more closely to what you're going to use that system for. So whereas a general purpose thing like Windows, it just says, yeah, I'm formatting it, I'm partitioning it, I'll let you know when I'm done. Something like Linux gives you actually more control over what you're going to do. Everyone happy with that? So I'm keeping an eye on the slide numbers. I'm trying to decide whether to take a break or whether to just power through, particularly if we've got to get to campus. I think we'll power through just now. Okay, so we have to do things within a directory. Open files, delete files, nothing major, nothing that you don't already know. But of course, the operating system has to provide these functions for you. This isn't something that every user writes or everyone who writes a program has to redo. You just ask the operating system to open a file, write to a file, delete a file. And organize the files. And one of the things that the operating system has to do is make sure that the files can be accessed efficiently. You don't want to say open, you don't want to open your MP3 and be sitting there while it's going, oh yeah, MP3s, let's see, they're in partition 2, and they're in a directory called music, and in a subdirectory called Simple Minds, the worst band in the world, and a file name called Alive and Dying. Yep, here you go, here's your file. You wouldn't hang about for that. So you want to be able to get to access a file quickly. And you also need to have something that's robust enough to have duplication in there. If you've got multiple people using a system, odds are that at least 2 of them are going to have created a file called dummy.txt or cv.doc. So they're different files, but they're the same name. We actually also have the other issue. We have files that are the same, but people have different names for them. And again, those MP3s could be an example. They're exactly the same data in them, but somebody might call them Simple Minds Alive and Kicking. Someone might call them Alive and Kicking Simple Minds, however they want to recognize them. We also want to give a way of grouping files. So in the beginning, we didn't really have that. We basically had one big directory, all your files were in one place, and we had that problem with naming. If everything is one place, you clearly need unique names. Otherwise, how do you know which dummy.txt are you going for? We also don't have any way of thinking about the files. They're all just in one big lump. Exactly the same way as your grandmother saves all her files. All in one big lump in one place, usually the desktop. And you just go on, and there's just piles and piles and piles and piles of files, and nobody can ever find anything. So we start to think, well, maybe we can be a bit more organized about it. Maybe we could have a couple of levels. So here's an example where it's a multi-user system. Each user has their own directory, and then they can store their own files in that directory. So that's a wee bit better. So we can have two people calling a file A. Everybody's called a file A. We can get to things a bit more efficiently. If you know it's user 3, you can go to user 3's files, but we still don't have any grouping. So we can move on and think, okay, well, if we can have a second level, maybe we can have a third and a fourth, and that takes us to the one that you're familiar with just now, a tree-style directory, where you create directories, and those directories can either have files or other directories. And that can go down and down and down and down as many ways as you want. And that's really helpful because it's efficient. You know, if you want a particular file, you say programs p list, and you just work your way through the tree to each level. And that's very quick. They are grouped. So we can say, right, all our mail stuff is in our mail directory. Cool. It's all here. All the programs that are to do with mail are in the mail programs directory. So it's grouped, and it gives us something to work with to understand how the files are organized. And it gives us a way of accessing all the files with a unique structure. What file do you want? I want, whoops, volume C, spell, mail, PRT, last. Again, you'll have seen that something like this. So we have this, which is an absolute link to that particular place. In other words, it starts at the top and works its way down. So that's an absolute link. We could also have a relative path name. So if we start at spell mail prog, spell mail prog, we could change into the mail directory by going up one. And that would be a relative move up one level in the tree. Or we could move down one by saying CD one down. So we can either access things in an absolute manner from the top of the tree, or we can access them based on where we are. So if we're in prog, we can simply say spell, and it knows that we mean the spell that's in prog. Or if we're in prog and we say list, it knows we mean list. And the operating system doesn't think, oh no, you mean this list all the way over here. That wouldn't make sense. So this gives us absolute and relative access to every file on our system. And the work that we do is based on our current place in that tree file, our current directory. And there you can see some commands that will actually work in your Windows system right now. You can make a directory and give it a name. And yeah, it is Connor. All modern systems use that kind of tree structure. Some get a wee bit more complicated and they use not a tree. Now the difference, so just to be clear, this is a tree. There's no recursive links. There's no sideways links from here to here so that you could have a loop. Okay, so you can't link this one to this one. Some systems like Linux though do allow you to do that, and they actually have a specific link command. So you create not a tree, but a graph. And there's a good reason for that. So say you are writing a word processor, and that word processor has both a dictionary and a spell checker. Now, how you work the dictionary and how you work the spell checker, the code for that is different. But both of those use a list of words. And why would you keep two lists of words on your system? So dictionary sees its list of words as W and points to this list. Spell checker sees its list of words as words and points here. So instead of each line in the tree being unique, we suddenly have a closed graph. So we can work our way through. That has its own issues. So we've got a couple of different names for things. Here we've called the word list. Its actual name is list. Dictionary calls it W. Spell calls it words. But they're pointing to the same thing. If, and the reason it call it the same thing is because they also have a list for themselves. So here it's a list of the incorrectly spelled words. So spell checkers call something list for its incorrectly spelled words, and it's called words for its word list. So it starts to get a bit more complicated. If you delete the list in dictionary, for example, you need to make sure you get rid of this too. You can't just leave that sitting there. So you have to get rid of everything underneath it. That becomes trickier when more than one thing points to it. So say dict deletes W. Well, W is just pointing to list. Do you delete list? Well, no, because words also points to list. So you need to keep a note. It's called a back pointer. And in list it says, okay, I'm pointed to by here and I'm pointed to by here. So if one link is changed, list will hang about. But if everybody deletes it, they go, oh no, I'm not needed anymore. I will silently expire. If that's what you want to do, because it's quite possible that that's a file that you don't want to lose. In other words, it might be a system resource. But just because nobody's pointing to it just now, doesn't mean nobody will want to point to it later. So it might simply say, okay, nobody's pointing to me just now, but I won't delete myself. I'll just say, yeah, I don't have anybody using me just now. So it starts to get a wee bit more complicated where we have links, where we have to resolve that link to understand what we're pointing to. And then we end up with things like this, where it can start to become a lot more tricky. And again, for those of you that are doing Linux, and those of you that have installed Linux for this, you'll know that there's a link command where you can set that up. So you say link, give it the name that you want to use and point to something else. And that allows you to use the name that you want. Where we have that and where we have multiple pointers creating wee loops and all sorts of things happening with book pointing to AVI, which points back to book, it becomes a bit tricky. So we can either say things like, well, no, you're not allowed to do that, or you can do something called garbage collection, which is to say, every so often you go through this graph and say, have we any dangling links, anything that doesn't point to something that should, anything that points to something that's now deleted, and we do the garbage collection to make sure that all the connections are okay. Everyone okay with that? Okay. Next thing we want to think about is mounting a file system. And again, those of you that just work on your own Windows machine don't really think about that too often. Maybe sometimes when you've put in a USB drive and you pull it out and Windows complains that you didn't actually unmount it properly, or eject it, I think Windows calls it. But all file systems have to be mounted. In other words, the storage devices have to be accessible to the file system somewhere, and that's called a mount point. Quite often that's taken care of automatically. And if you stick a USB drive in your system, it will be automatically mounted. The operating system will detect that you've got a USB drive, and it will put something into your file manager saying USB drive Fred. Other systems make you mount the system manually. And even Windows acknowledges this, so you have a OneDrive. You can add OneDrive to your file system on Windows, but you have to explicitly point to it. So on my file manager in Windows, I've got a pointer to my OneDrive, which means I can save things to OneDrive or I can save them locally, and I don't now have to think about it. As far as I'm concerned, it's just a storage space. And if I want to copy something from one place to the other, the operating system sorts that out for me too. So quite often we don't think about mounting as being an issue, because particularly for our consumer focused systems that we're often on, it's taken care of automatically, because you don't want people thinking, what's mounting? Why do I have to mount? What are you talking about? So quite often they'll be done automatically, and they'll be put in places that we would expect to see them. So different drives get different drive letters, for example, or different names with an icon on the desktop, whatever it's going to be. So that's quite often at the root of our system. There's nothing that says it has to be at the root. You could mount them anywhere you want. So on Linux, I think it's /usr/dev for devices. Is that right? Something like that. And all your devices, your hard disks, all your I/O devices, in fact, will have a mount point in there. The other thing that we'll want to have the operating system take care of is file sharing. Being able to share a file between individuals or groups or both. And again, we saw that earlier when we looked at the Mac system, way back. Because we had some things that were individuals. So Greg, a person. We had staff, that's a group, and everyone, which is a group. And we can give specific permissions to individuals and or groups, and they can be different. So the operating system takes care of that using file permissions and directory permissions. Of course, we have to put in some sort of protection to ensure that we only give access to files that we want, that they're only allowed to do certain things. So again, you saw in that some users were allowed to read and write, so they're allowed to alter the file. Some users were just allowed to look at the file, and some users were locked out altogether. Everybody in this meeting has a OneDrive, which is all stored in one server in essence. But I can't get access to your files and you can't get access to my files. Unless, of course, I choose to. So all the module materials which you have are stored in a file. It just happens to be a OneNote file. This is stored on my drive, and I've given you a link to it. That's the link there to my SharePoint in my personal directory with Tony Gurney at UWSAC UK and a link into the file. But of course, I haven't given you edit on this. I've only given you view because that's for a guest contributor. So you can look at it, but you can't go in and start typing stuff. At least I hope you can. But of course I could on mine. So we have to decide what sort of permissions we want to give people, what sort of access we want to allow them. And we're going to have to set up some sort of device to allow us to share those files across a network. There's one called NFS that you'll see quite often. That's quite a common one to use. To do that, we'll need to identify people. So we start and get into the idea that the operating system also has to keep track of users, so they'll have an ID. We might want to group users together. So we've got the sales, we've got marketing, we've got accounts, we've got whatever. So the users can get put into groups, and the group will have an ID. And then we can use all those to allow us to share, either on our own physical machine or remotely over a network. And that's exactly what I've given you here. I've allowed you to access it over a network. And we use a distributed file system to do that over the web. And you probably saw, I hope you noticed when I brought up that link, that it started off HTTPS, which said it's an HTTP, Hypertext Transfer Protocol. So that means it's going out over the internet. S means it's secure. And then a URL that points to where that file is somewhere out there. And the reason we had all those characters at the end is because that's a way of giving us a unique identifier for that file. So every file that's created on OneDrive gets that 64 character, I think, unique ID, which means you can access every particular file using that same type of URL. So we have different ways of setting that up. Quite often we use a client-server model, so that there's a server sitting somewhere, and that's got its own files and that's got its own access. We're on our clients here, and our client accesses that server, and that's what happens when we access OneDrive. There's a OneDrive server. We're accessing it, say, from our Mac client, and that allows us to get access to it. But of course, we need a protocol to do that. We need a way that we have agreed that we will access those files. And there's a few. We've already spoken about NFS, and that's a very common one because that came out with some of the early Unix systems and has persisted. Often new ones come in to give you extra features, so CIFS for Windows. And we need all the subsystems to let us also access them. So that one said http:// and then it gave a name. Well, that name's just a bunch of characters. Where's that actually going on the system? So we need something like DNS to give us our name. That's a domain name system. We need LDAP, which gives us user information. So all of these systems come together to allow us to do that kind of stuff and to allow us to decide what we want to share, with whom, and what privileges we want to give them for each particular file or directory. For Unix and for your Linux systems, the access mode is set up like this. So we have read, write, execute, and we have 3 chunks of read, write, execute, and it uses a binary format. So it uses 1 byte. It uses 1 word. We have 3 numbers, each of 1 byte. And the numbers correspond to a binary read, write, execute. So here we've got read is on, write is on, execute is on, that's 111, that gives us 7. For public access, read is off, write is off, execute is on, that means it's 1. So you'll see these when you look at the system, and you'll see what access rights you have for the owner, the group that owner is a member of, and everyone else. And you can change those. you can change the rights that you give people. So you could say, no, I don't want anybody to have access but me. So you could say chmod 700 and then the file name. And that would say, well, owner gets everything, group gets 0 read, 0 write, 0 execute, and public gets 0 as well. So it's entirely up to the user how you want to set those up. That's for a command line interface for Unix. Something like Windows will do it slightly differently. It will try and make it a bit more nice. It will say, okay, here are all the groups and all the users that we have. Choose one in this box. And then in this box, say, what do you want to give them? What do you want to allow and what do you want to deny? And you can see there's different types of permissions there. Execute, read, write, as with Linux, but some others as well. So Unix puts write and modify in the same group. Windows decides to have a separate one for those. So you'd set it in Windows like this. And if you go into Linux and get an extended file listing, it will give you the access rights in amongst all the file names. And it will tell you who gets to read access, who gets to write access, and who gets to have execute access. And one extra one which specifically says whether we're looking at a directory or not. So the directories have a D against them in the files. Just have the dash. And I'm glad I powered through because that's us done. Does anybody have any questions? Like pause to see if anything comes up in the chat. For the slow typists among us. Okay, I'm not seeing anything come up on the chat. I'm not. Oh,
Tony, can I just get a word with you before you head out?
Yep.
Cheers.
okay, I've not seen anything come up in the chat. I'm not seeing any hands pop up. So let me stop the recording there. Bye.